Welcome you all to the Spark Research YouTube channel. This is Dr. Chandra, Assistant Professor in the Department of ECE. So this is another series of this analog and digital communication. So here primarily we are going to take some questions which has already been asked in GATE 2025, which particularly belongs to the first two units, right? So let's talk about it. First of all, here is your overview. This course, the analog digital communication, is one of the important course, and if you can solve the questions, definitely you can score the marks in the range of 8 to 12 marks, and maybe sometimes higher, right? So here is the syllabus for your subjects. So let's take the contents. So this GATE 2025 is has been organized by the IC Bangalore, IIT Roorkee Valley, and the question 14 number. What is the question? So consider a frequency modulated FM signal, that is FT is equal to given AC cos omega CT plus 3 sine twice pi F1t plus 4 sine 6 pi F1t, where AC and FC are respectively the amplitude and the frequency in hertz of the carrier waveform. Right, the frequency F1 is in hertz. Assume FC is very high compared to the F1, that is message signal. So the question is being asked that what should be the deviation, peak deviation of the FM signal, right? So first thing is that okay, so according to answer key, your answer A should be correct, that is 15 F1. So first thing is that uh, why, like in the FM modulation, whenever we are talking, that is frequency modulation, so frequency is going to change with respect to the message signal, right? So here omega CT, that is why omega CT and plus message information is there, right? So omega CT means this angle will change with respect to this. So now question is that omega c, definitely the angle will change, but what will be the maximum change? So that is the peak frequency deviation. So this is the question, right? So let's find out how to do. So like this is your message signal and this is your carrier frequency, and you can see here the frequency is little bit lesser. In this region frequency is very high because amplitude is higher, right? And then the frequency is very less in this region, amplitude is negative corresponding to that. So this is actually the FM signal where frequency is changing. Initially it is very low, in the mid section it is very high, then low, low, and very much low, right? And while amplitude is fixed. So this is something like that. Your train or bus is carrying the passengers, so train bus is your carrier signal, and passengers can act like the message signal, and modulated signals means both of you are traveling right together. So how we'll find out the deviation? So the formula which we are going to use it here, that is d omega by dt. So your del f is equal to d phi by dt, and since omega is equal to d phi by dt, so del f, that is twice pi f. So del f will be 1 by twice pi and d theta by dt, right? So maximum we have to find. So here is your information is given, that is theta t is given, that is omega c is, so in the question only it has been given, right? So the, if from here you can see that the omega c is there, that is f of c, and the message information, that is it has been given right here. So now we will find out the f of I, that is instantaneous frequency, right? So we will find out d theta by dt, and then we will divide by twice of pi. So how can we find out? So just put this angle d theta by dt and take the differentiation with respect to the dt, and we can get the values after dividing it by twice pi, that is f of c. So that is the carrier one only, and then the thrice of f1 cos of omega ct with respect to this, and 12 of f1 cos of 6 pi f1t, right? So here fc is okay, fc is the the carrier frequency, and from this fc what will be the maximum deviation? So maximum deviation may be possible if cos theta is equal to 1 plus minus 1, if it is plus 1 or whether minus 1. So Fc, and if it is cos theta is suppose plus 1, then Fc and plus 3 of F1 and plus of 12 of F1. So total 15 of F1. Right. So this is the maximum possibilities because cos theta may have the maximum value of 1. So the maximum deviation is your 3. So F from Fc only, that is from carrier wave. So that is your 3F1 plus of 12F2, that is 15F1. So as per answer key, it should be 15F1, right? Okay, now let's take one more question. So in this question, what is that? Consider massive signal MT, which is band limited to minus omega to omega, where omega is in hertz. Consider the following two modulation schemes for the massive signal. So first of all, in question, it has been given the massive signal is a band limited. What is the meaning of the band limited? Means it have the fixed bandwidth in this range, means masses have the information only in this range of frequencies. Out of this range of frequencies, masses doesn't contains the any information. That is the meaning of the band limited, right? And now question is being asked about the double sideband suppressed carrier, that is DSBSC, that is equal to given ACMT cos omega CT, and then amplitude modulation. So this is DSBSC and this is your pure amplitude, that is AC, plus into 1 plus mu of MT and cos omega CT. AC, FC are the amplitude and frequencies of the carrier respectively in the case of AM, and mu denotes the modulation index, right? So mu is your modulation index, that is Vm by Vc, right? And so now the statements are there. So an envelope detector can be used for demodulation in DSB-SC scheme if MT greater than 0 for all t, and an envelope detector can be used for demodulation in AM scheme only if MT is greater than 0 for all t, right? So first of all, the what is this envelope detector? So definitely envelope detector is being used to detect or recover the original masses from the detected modulated information. So that is correct one. So as per answer key, your option A and D are correct, means first is true and the last one is false. So let's see how. So here is your envelope detector circuit. With the help of this envelope detector circuit, you may detect the information. So suppose this is your modulated signal, right? This one, this is the modulated signal, and this is the actually the envelope detector technique by which we are going to detect the variation in the amplitude, right? So in this manner, actually we will take the envelope, and so with the help of this envelope we can detect the information, that is message signal. So that is exactly the target. So in case of DSBSC, right, so already message is given, that is AC MT cos omega CT, and in case of FM, AC 1 plus of MT cos omega CT. So here now you can see, like if this is the modulation, so what will happen, M of T must be greater than 0, right? If M of T, like suppose the recovered signals, if it is less than 0, then how is it possible to recover? So if empty is not less than 0, means if it is greater than 0, then definitely we can detect, right? But if it is less than, it's not possible to detect, right? So that is why option 1 is correct. In second case, here it is asking AC, that is 1 plus mu mt and cos omega ct. In this case, like 1 plus mu mt, this entire amplitude must be greater than 0, right? Otherwise what will happen, again it is difficult to reconstruct the information. So in that case, mt may be greater than 0 and sometime may be less than 0, but the overall term, that is 1 plus mu mt, must be greater than 0. So in certain case, let's suppose mu mt is equal to minus 0.5, still it will be 1 plus and minus 0.5, 0.5. So greater than 0, so in that case also we can detect, right? So overall, 1 plus of if mt is greater than 0, it doesn't mean that means the you can detect the envelope using the envelope detector. So Actually, the meaning is that 1 plus of mu empty must be greater than 0, right? So sometime empty may be less than 0. So that is why option second is not correct. So here is the more detailed explanation here. So MT for DSBSC, AAC, M of t and then cos omega ct. So M of t must be greater than 0 in this case. Then only you can detect the message information using the envelope detector as you saw, right? And in the second case 1 plus of mu empty must be greater than 0, but certain cases even empty is greater than 0 definitely we can construct, but some cases even if empty is less than 0 still you can construct, so that is why this is false. Okay, so here is the DSBSC signal, that is equation is this, and only it can be detected if empty is greater than 0, and here 1 plus of mu empty should be greater than 0, right? So that's all in this session, and thank you to join the sessions. We'll come with some more questions which has already been asked in another get year. Thank you to join.